Hello everybody, welcome back. So this is the first video covering chapter 2 of my proofs book. Chapter 2 is on direct proofs. But another theme of chapter 2 is that this is the chapter where we're going to start introducing absolute rigor in our work. Chapter 1, for pedagogical reasons, we were a little bit more lenient. We wanted to see some more fleshed out, interesting proofs with many steps in the argument. But now we're going to go to the basics. And if you demand rigor, the first step in that process are definitions. If your professor asks you to prove that every perfect number is even, you would probably ask them, what the hell is a perfect number? Definitions are really important in math. They give us precision. But they are also subjective human choices. The math itself is deep and intrinsic. The definitions, those are inventions. They are human choices in order to make it easier to discuss the math. And deciding on a definition can be difficult. There are some legitimately great definitions in math. Definitions which, if you can really understand the theory behind it, you think, wow, this is not an obvious thing to define. It's not obvious to define it in this way. But whoa, did they nail it. And it's absolutely the perfect definition. There are many examples. We'll get to those. In my real analysis book, I highlight one in particular. And some definitions in math took literally decades to decide on. I think the definition of a group is an example of this. So if you take a course in abstract algebra, probably the first thing you'll study is group theory. A group is a very, very fundamental definition in math. Like the definition of a group is extremely fundamental in math, and yet I think it took literally decades with many very top mathematicians proposing all sorts of definitions before they finally settled on the one we use today. And it's a great definition, so they ended up in a very good spot. It can be very challenging to precisely write down what something is and do so in a way that excludes the things that it is not. And also do so in such a way that makes it easy to work with that definition and to apply it in your proofs and in your work. So as a fun example of this, imagine that you were writing a dictionary and you were trying to define what a sandwich is. Okay, like a sandwich, that's something that you eat. So please do this. Please pause the video just for 30 seconds and write down what you think is the definition of a sandwich. Okay, so hopefully you got one. Hopefully you just made an attempt. You don't have to overthink it. But, okay, hopefully you have one. So here's a question. Does your definition require bread? Does it require meat, cheese, vegetables? Do you require a certain quantity of any of these things? So think about the consequences if you do or you don't include those. Does it attempt to classify those things abstractly? If you demand, for example, meat between bread, okay, so many definitions might include that, you do rule out things like vegetarian sandwiches or something like a grilled cheese sandwich. Are you okay with that? And if you just say meat between bread, you might include something like a hot dog. Do you want a hot dog to be considered a sandwich? Are you okay with that? And what counts as bread anyway? Is it any carb? Is a quesadilla a sandwich? You would have to be very careful to define each of the terms that you are using in your definition, right? If in your definition you use a term, you should also have a definition ready to go for that term as well. So here's another question. Must bread be on top of your sandwich? What about on the bottom? Do you want to include something like an open-faced sandwich? There are things that are called sandwiches which have bread on the bottom, stuff on top, but just no bread on top. Open-faced sandwich. Do you want to include that? Well, probably most people would want to include at least some of those, but they wouldn't want to include, for example, a pizza, which might be accidentally included in any definition that allows for some other open-faced sandwich. Or what about an open-faced PB&J that's basically just bread with peanut butter and jelly? For some reason, that doesn't feel like a sandwich anymore. And certainly not just toast with butter on it. That definitely shouldn't be a sandwich. So leniency with your bread is important, but if you're too lenient, you might accidentally include those other things, or you might include a burrito or a veggie wrap. And if you don't want those, but maybe you do, this is your conception of a sandwich. But if you don't want those, then demanding 2 slices of bread would also exclude like a submarine sandwich. So you might say, okay, so a sub is okay because it leaves maybe one side open. Maybe that's sufficient for a sandwich, but so does a taco, right? Or a bread bowl of clam chowder. I don't think you want a bread bowl of soup or a taco to be considered a sandwich. So a club sandwich is probably also okay, right? Even though it goes bread on the top and bottom and bread in the middle. So you have like a 3rd slice of bread, but probably that's okay. But if that's okay, let's see, what about a Big Mac? I guess that's probably a sandwich. What about a slice of lasagna? Maybe not, even though there's carbs interlayered. What about a mushroom burger? Can a sandwich be sweet? If you say it can be, if you're okay with that, what definition would allow this without including something like a Pop-Tart? Is a cookie? Could a cookie be an open-faced sandwich? So as you can tell, it is sometimes very difficult to get a definition exactly right. Now, indeed, when considering the statement, every perfect number is even, for example, the example I gave you at the beginning, you probably are saying, okay, we should definitely define what a perfect number is in order to proceed with any analysis of this statement. But it's also important to find what an even number is. Now, you might intuitively already know what it is, and you might say, oh, that's good enough for me. But no, you really should have a definition, and it should be precise. Even if you intuitively know, the even numbers are 2, 4, 6, 8, 10. Well, first of all, do the odd numbers count? Okay, you'd have to decide on that. Does 0 count? You have to decide on that before you begin. But even if you have some sort of, the even numbers are start with 2, go to 4, 6, 8, and just keep adding 2 as many times as you want. That is a very bad definition. Could be a correct definition, especially if you say you can also subtract 2, because spoilers, even numbers can be 0 or negative. But that definition is not a good one because it's very hard to work with that definition. Okay, so there are many ways to define an even number, but first of all, we should all be on the same page as to which definitions we are working with. And we should have it be precise, and we should write it out in a way that's very usable. Okay, so the working mathematician, using the definition of an even number in their proof, can use it in a good way. Okay. So, and even we should probably define what an integer is. Well, okay. So there are some things which technically, as mathematicians, you should define all the way down. And there are certain statements which you should, every statement should be proven beyond the axioms. However, for a class like this, we don't want to be fussing about at the absolute bare minimum level. So we will assume, first of all, that we know what the integers are. So these are the integers. Okay, so that is a set of integers. We will just assume that as a basic part of the knowledge for this chapter and this course. And we will also assume one basic fact about the integers. So this is fact 2.1 from the book. The fact is that the sum of integers is an integer. So if you add together 3 integers, you're going to get another integer out. The difference of integers is an integer. The product of integers is an integer. And every integer is either even or odd. Okay, so I'm calling it a fact because unlike our propositions and theorems, lemmas and corollaries, I'm actually not going to prove this fact. Now, you could prove it if you go all the way down to, okay, what is the definition of an integer? And then you could, and then what is the definition of adding integers, subtracting, multiplying, and then you can, follow the definition through. And it is provable, but we're not going to prove it here. So I'm just calling it a fact. It's a fact that you can use freely in this chapter. But that's about it. You can view those as sort of the axioms of this course, and basically everything else we are going to be proving. So we're going to start that next time. Next time we will start section 2.1, whose title is Working working from definitions. So come back next time. We will define an even number, an odd number, and proceed from there, giving examples and proving things. All right, see you next time.